today we are divided for the primary set. This is the final we have till six chapter. Chapter 1 probability. Okay, for this chapter we got the important probability rule. The first rule is the Edison rule. Edison probability rule. PA plus D equal PA plus PB minus DAB. The second rule is the coefficient probability rule. In general, P A1 plus Q AN is the sum of PAI array from 1 to n, and then minus the sum of PAI AZ I smaller than Z. Plus the sum of PAI AZ AK I smaller than Z smaller than K, and then minus the last term minus 1 to power n minus 1 P A1 A2 to AN. And the general Edison rule. But we only ask you to n equal 2, 3, or 4. The problem of this exercise we only apply when the sum of 2 or 3 or 4 events. The second probability rule is conditional probability rule. PA given B equal PAB divided by PB. So PA given B factor in the probability of A on the sample space. B. Okay. The third rule is the multiplication probability rule. The multiplication probability rule. P A1 A2 P AB equal PA times PB given A or PB times PA given B. The general formula PA1 A2 AN, so equal PA1 times PA2 given A1, so on PAN given A1 to AN minus 1. Then we define two independent events. Two events A and B are both independent. If PA given B equal PA, or PB given A equal PB. or PAB equal PA times PB. Yes, the third rule, the fourth rule, we call the probability G. A1, A2, AN, probability P1, P2, so on, PS. A given A1, A bar given A1, A given A2, and so on. A given AN, A bar given AN. Probability here's Q1, 1 minus Q1, Q2, 1 minus Q2, so on, Qn, 1 minus Qn. So for probability we have two formulas. The total probability rule is to compute PA. So equal the sum of PA1 times PA given A1 plus 2 PAN times PA given AN. So PA1 is the P1, PA given A1 is Q1, PN, QN. The total probability. And the bias rule. Bias rule is used to compute the P AI given A. So equal PAI times PA given AI divided by PA. Equal PI QI divided by the sum of PJ QJ. So you range from 1 to n. And then the last rule, the fifth, the Bernoulli rule. P and K. P and K is the probability such that there are K successive our n independent Bernoulli child equal CKN P power K Q power n minus K. Where is the program of the first chapter? You student number how many? 5. The first is the rule, the second conditional probability rule, the third multiplication probability rule, the fourth probability G implied total moment and bias rule, and the fifth Bernoulli rule. So we are given an exercise to apply some of these 5 probability important probability. The second chapter we study about the random variable and probability distribution. Okay, the first section we call the PD of discrete random variable. So the PD of a discrete random variable is given by a PDT. It's a table consider 2 rows. The first row represents the possible value. The second row represents the associated probability P1, P2, so on. And from the PDT, we find the PMF. It's a function f small x, so it's the probability such that x is x small. So it's the pi if x is xi. For I range from 1, 2, so on, and for 0 otherwise. The PMF. And from the PMF or PDT, we compute the CDF. What the CDF? The CDF. Ft, the probability such that x smaller than t. So it's the sum of p x is xi such that xi smaller than t. So equal 0. If t smaller than x1, is the p1 from x1 to x2, p1 plus p2. From x2 to x3, so on. If we know the PDT, we can compute the characteristics method. First thing we recall three central location, three measures of central location. The first is the mean. So to compute the mean, we take the value xi multiplied with the probability and we take a sum. The second is the median. Median satisfy two equation. This two probability is at least a half. And then mode. Mode is the value that has the likelihood probability. The value that has the likelihood probability. And then we call two measure of variability. They are variance and standard deviation. Variance is ex square minus mu square. So the sum of xi square pi minus mu square. The standard deviation is square root of the variance. Okay, the content of PDF discrete number. Similarly, you will install the PD of continuous random variable. The second section. Second section. PD of a continuous random variable. Continuous random variable. The PD is given by function f(x) does satisfy three requirements. The first density is non-negative for x in R. The total density must be 1. If you want to find the density in interval AB, we take interval from A to B or the sum of density in AB. And three requirements. And then continue. The validity of PMF for this grid for continuous is PDF. And from the PDF we compute the CDF. It's the pH more than T, so integral from minus infinity to T of fx dx. Today we did all the characteristic method. First need the mean. You take x times fx and then we take the sum interval in x fx dx. Median. How to find median? I will solve the question. Fm is the CDF is and mode. What is the value that the PDF is the maximum? It's the three methods of central location. Then two methods of variability, variance, and standard deviation. Variance square. So it's the integral of x squared fx dx minus mu squared. And standard deviation. Sigma square root of Vx. Okay, we finish the second section. And now, the third section will show the important property of CDF. We define 5 important property of CDF. What are property of CDF? Remember? The first, the value of CDF is between 0 and 1, and the second, the CDF is a non-decreasing and NF continuous or not. The second F is non-decreasing. The third F is the net continuous. And now the fourth property, the limit of Ft when t tends to minus infinity is a 0. And the limit at plus infinity is 1. And the fifth property, you want pH smaller than X smaller than B, you take Fb minus Fa. Here are 5 important properties of CDF for both discrete and continuous random variable. And now we consider if X is continuous. What the special property of continuous random variable? You remember? if x is a continuous random variable, then the third property, net continuous, become continuous. Moreover, the primitive of CF is a PDF. Because the CDF is the the CDF is integral PDF, so the derivative of CDF is the PDF. And then the fifth property become these four probabilities are equal. N equal FB minus FA, so it will form A to B of Fx dx. Well, here are important content of the second chapter. We call the first is the PD of discrete, the second property of PD of continuous and variable. The third section, the property of the CPF. And now the fourth section, what the fourth section? We got some important probability distribution. What the first? Bernoulli distribution. With parameter P. So, you remember Bernoulli? Bernoulli then only take two values here. One, P1 is a P, P0 is a 1. 1 minus P. So what is the PDF or PMF? Fx, Px is a small x, so equal P power x, 1 minus P power 1 minus x if x equals 0 or 1, n equals 0, other 1. And for the PDT, it's easy to compute the mu and sigma squared. Mu is 0 times 1 minus P plus 1 times P, so it's P sigma squared is a PQ. So for Bernoulli distribution, it's very simple. What is the next? What's the next distribution? The next distribution we compare binomial distribution and Poisson distribution. B and P compare with Poisson distribution P nada. Okay, firstly we the definition. What's the definition of binomial distribution? When we count the number of successive hour and independent Bernoulli trains. And for Poisson distribution, when you count the number of successive inner periodic time, different the definition. And the second comparison, what is the PD? The rate of birotation from 0 to n, where probability at the point k, ckn, p power k, q power, and minus k. Right? And for Poisson distribution, from 0 to post infinity, right? It's a natural, the set of natural number, right? Where probability at point k, e power minus lambda power k over k factorial, right? And then what's the third comparison? Is the comparison of characteristic method, right? Mean is NP sigma square, NPQ, and mode between NP minus Q and NP minus Q plus 1. And now for Poisson distribution, mu and beta are the same. Okay. We can discrete important discrete distribution, and now we go to continuous. Two important continuous distribution. What are they? The normal distribution of Bell-shaped distribution, and mu sigma square. What is the mu? Mu is the central location. Sigma square is the mass. And what is the PDF? The PDF is a 1 over f small h is a 1 over square root of 2 pi sigma square e power minus h minus u square over 2 sigma square. And now when you draw this graph, the graph of this function, it has a bell shape. This bell is symmetric by mu, and the shape characterized by sigma. For normal equation, you should remember the standardized rule. What's standardized rule? If H follow normal equation between mu by sigma square, then we change the variable H. We take H minus its mean divided by its standard deviation. Follow? n01 and standardized rule. And 3 sigma rule. What 3 sigma rule? If I follow normal distribution between mu by sigma square, then nearly 100% value of x belong to which region? Belong to the region mu plus minus 3 sigma. It contains about 99.7%. And now we find the CDF from x. Is the phi t minus mu or sigma. The CDF of x is the phi of t minus mu or sigma, where phi t is the CDF of what? Of z, of n01. What the definition of phi t? Integral from minus infinity to t of 1 over square root of 2 pi e power minus x square over 2. Yes. And what is the property of this function? It must that phi minus t is a 1 minus phi t. And if you want to find the exercise, we only ask you to answer the question 5p h more than a. P h more than a equal phi of a minus mu over sigma. And ph greater than a is 1 minus ph smaller than a. Ph between a and b is ph smaller than b minus ph smaller than a. Okay, for the norm distribution, we only remember the important content. And now we recall the last point of this chapter. We call the exponential distribution. Exponential distribution in what the PDF? The PDF dana e power minus dana x, if x positive is 0 other 1. Okay, from the PDF we compute the CDF. One minus e power minus lambda x, if x positive, 0 other one. And the characteristic method, what the mean? 1 over lambda. What the variance? 1 over lambda square. So sigma is a 1 over lambda. For exponential distribution, you should remember the memoriness property. The memoriness property states that ph greater than t plus a given h greater than a equal p h greater than t. So equal e power minus lambda t. For t and a positive. Okay, we finish the second chapter. The second chapter is rather long. We call the third chapter. The third chapter. Vector Okay, the first step we consider the discrete case. Pair of two discrete random variable x and y. So the first point you we call the Zoid PD. The Zoid PD of the vector xy is given by the Zoid PDT of the Zoid PMF. What the Zoid PDT? The Zoid PDT is the table. I take the value x1, xi to xn. Y take the value y1 to ym. And the probability is P11, P1J, P1M. The sum of the first row is the P1 point. Ready? The CI row P1, Pij, Pim, and the sum of CI row is the Pi point. The factor is the pH. The last row Pn1, Pnj, Pnn, and the sum of the n row is the Pn point. Similarly, to compose the marginal PDT of y, we take the sum by column. Get P point 1, P point J, P point M, and the total sum of the table must be 1. The Zoid PDT. From the Zoid PDT, we find the Zoid PMF. The Zoid PMF. The Zoid PMF is a function fxy. So defined by px is a small x, y is a small y. Okay, so pij. If x is xi, y is yz. The y is 0. Here's the second point. From the table, we find for the PD of a pair of two distribution, there are 3 PD. Zoid PD, marginal PD, and conventional PD. Okay, so to find the marginal PD, you take the probability by row, we obtain the marginal PD of x. You take the sum of y by column, we have the marginal PD of y. So we have the marginal PDT of x. Is the PD of x, I take value x1 to xn. The probability P1 point, Pi point, Pn point. And the marginal PDT of y take value y1, yj to yn. Probability P point 1, P point j, P point n. And Continue to find the conditional PDT. The conditional PDT of x given that y is the yz. I take the value x1, xi2, xn, and what we want to keep. We take p 1z over p point z. Pij over p point z. The last one pnz over p point z. And the conditional PDT of y given that x is xi. Y take the value y1 to ym. Probability p I1 over pi point, pij over pi point, p im pi point. And we look at the PDT to find the marginal and the conditional PDT. Okay, we finish the first case. So we have discrete random variable. The second case, we have two continuous random variable. The factor, the Zoy of two continuous random variable is given by the Zoy PDF. It's a function fxy that satisfies three requirements. What's the first? The density is non-negative in R square, and the total density in R square must be 1. And if we want to find the density in the region D, we take the sum of density in D. Okay, the Zoy PDF. And from the Zoy PDF, you can compute the marginal and the conditional PDF. The marginal PDF. The marginal PDF of x is fxx. So, to compute the marginal PDF, we take the sum of Zoy PD. The marginal PD is the sum of Zoy PD. So the sum is the integral in of the Zoy PDF fxy respective to y. The y f y is the integral in of fxy dx. Jadi the conditional PDF. Fx given that y is the small y x. So to compute the conditional PDF, we take the Zoy PD divided by the marginal PD. For all x in R. Ready to find the conditional PDF of y given that x is small x of y is fxy over fxx for all y in R. Okay. Well, we finish the second section. Now the third section, we call the measure of coordination. There are two methods of correlation, the covariance and coefficient of correlation. Measure correlation. Okay, we call the covariance. It's a COVS one. The definition is the mean of x minus mu x times y minus mu y. And the shortcut formula is the expectation of px y minus mu x times mu y. Okay. So to compute the covariance, you compute three mean mu x, mu y, and mu x y. Right? Where what px y? For this grid, we take the sum of xi, yj multiplied with pij. Right? For consider double integral in R square of fx, xy, fxy, dx dy. Okay. Today, mu x, the sum of xi, pij, or the sum of xi, pi point, or double integral in R of x, fxy, dx dy, or integral in R of x, fx, dx, similar mu 1. And then we must recall the meaning, the property of the covariance. Right? We recall and the second method is coefficient correlation. Rho xy, the square root of covariance divided by square root of standard deviation. So square root of variance. And then we recall the meaning and the property of rho xy. Right? So to compute the rho xy, right? We compute dx, dy, dx square, dy square, and dxy. To compute the coefficient correlation, we must compute this phi mean. Mean of x square, of y square, and of xy. Okay, for each chapter, remember, for each chapter you should redo the exercise of each section and the content of the third chapter. Now we recall the fourth chapter. You remember the fourth chapter? What the fourth chapter? The chapter of estimation. Which content of the what factor we must remember? We must recall. Chapter 4. Estimation. What's the first section? The definition of random shuffle. Most important definition in this chapter. Okay, we suppose that we observe population X, which means it's a mu X, mu is the EX, sigma square is a Vx, and the PDF of PMF of X is Fx theta. Of course, we will sigma square is a function of theta. Z1 theta, Z2 theta. And in this chapter, the main question of chapter 4 is estimate data. How to estimate data. Okay, firstly, because the definition of a random shuffle, what is a random shuffle? It's a vector x1, x2, so on, xn that satisfy two requirements. What are two requirements? Dn random variable are is of independent and identically distributed. With the population X as the definition of random shuffle. And we include two important statistics. Two important statistics are two estimate of mu and sigma square. What the estimate of mu is a random shuffle mean denoted by x bar magnitude. So x1 plus xn divided by n. Okay. And the second is the adjusted random shuffle variance s squared is the 1 divided by n minus 1 times the sum of xi minus x bar squared. So it's 1 over n minus 1 times the sum of xi squared minus n x bar squared. Okay. Now, you must remember the shuffling distribution of x1. Because the shuffling distribution of x1. for the something in the H bar, we must remember three important reasons. What are they? The first, the mean of the random sample mean is the population mean, right? And the variance of random sample mean is the variance of X divided by sample size, sigma square of X. The second case, if X follow normal distribution with mean mu variance sigma square, then X bar is also normal. Right? X bar is also normal with mean mu variance sigma square over N. And when X is normal, we have two statistics, is the Z statistic and the T statistic. What's Z statistic? We standardize this norm distribution. You take X bar minus its mean divided by standard deviation. So sigma square of N follow and 0. And the second statistic, you replace sigma by S, and this distribution, this statistic follow Steven distribution. And then, what's the second case? If X is so when X is not normal, we must suppose that N must be large. Then, what's X bar? You replace follow by approximately follow, and mu sigma square. So we have two statistics, Z and T. Z is the H bar minus mu over sigma divided by square root of N follow approximately N01. And T, we replace the sigma by S. Also approach N01. Okay? So we really remember this thing. When X is normal, T follows Steven distribution. Okay, for the first section, random sample. To remember the important content. It's not very long, very short. Remember what the definition of random sample. Remember two important statistics, and remember the sampling distribution of H bar. And now, the second section of this chapter, we answer the main question. How to estimate data? To estimate data, we use to estimate the point estimate and the interval estimate. Point estimation. For point estimation, we recall two methods. Two methods to find point estimation. The first is the method of moment. So to find theta hat the point estimator of theta by method of moment, we solve which system equation. We balance the theoretical moment of order k, so E h power k equal the empirical moment of order k, 1 over n times the sum of x1 power k plus 2 xn power k. So if we divide x power k by for k is 1 to r. What is r? I is the dimension of a parameter space. Dimension of parameter space. Okay. The first method, the method of moment. So to find the point dimension by method of moment, you follow two steps. The first step, you must compute R. Required by R. What is the dimension of parameter space? Then the second step is solve this system equation. We only consider R equal 1 or 2. For example, when x is a vector, I is 1. When x is a Poisson, I is 1. When x is a exponential, I is also 1. Only x is normal, I equal 2. When x is normal, there are two parameters, mu and sigma squared. X is a vector, there are only one parameter. The p Poisson is another, exponential is another. So for this exercise, you only define co-distribution. Vector, Poisson, normal, and exponential. Okay, the first method, the second method, the maximum time estimation method. Define theta hat and ML. Right. What is the maximum time estimation method? What the theta hat and ML is the apex of L theta. The maximum point of L theta and the maximum point of log L theta are the same. Right? Where L theta is the likelihood function. What the likelihood function is the joint PDF or PMF of the vector of the random sample x1, x2, xn. Okay. So how to compute the joint PDF or PMF of the random sample is the product of marginal PDF. So fx1 theta, fx2 theta multiply fxn theta. Okay. We shown here fx theta is a PDF of PMF of the population X. So we compute the likelihood function, and then we compute the log likelihood function. What log L theta? The log product is the sum of log, right? So the sum of log f xi theta. And then we solve the equation. The derivative, the first derivative of log L theta respective to theta equal to 0, and we solve the solution with the theta hat. And then we put the second derivative of log L theta. Respective to theta at the point theta hat must be negative to find the maximum point at the maximum negative. Okay, so we finish the point estimation. We refer the property of estimation. Unbiased estimation, consistent estimation, and efficient estimation. Property of estimator. Firstly, what unbiased? Unbiased, it means that the mean of theta and theta, or the bias is zero. The consistent, what is consistent? What is consistent estimator? If theta hat tends to two values, theta is the jumbo size and set to plus b, and the efficient estimators satisfy two requirements. What are they? Firstly, theta hat must be unbiased, and the second, the variance of theta hat is the smallest or the minimum. Our own unbiased estimated. Okay. Okay, now, but in the fourth chapter, you should focus on the third section, the confidence interval estimation. In the finding exam, we usually, of course, we will ask you one question about the confidence interval estimation, and the second question of this chapter, maybe we can ask you about the point estimation or the sampling distribution of each one. For the point estimation, the confidence interval estimation, we find the confidence estimation of two parameters. What are they? The mean and the population mean and the population proportion. So we have two formulas. The first formula we find confidence interval of mean is x bar plus minus epsilon. And then we consider three cases of CI of mu. For the first case, zero is z power 2 times sigma square root of n. If, of course, when we use sigma, sigma must be known. And what are the requirements? What are they? F is a normal or n is large. The second case, of course, the second and the third case we use S, so sigma square is unknown. What's the second requirement?
N is large.
Okay, N is large. X is normal. Continue. The second form. CI, 1 minus half of CI, P, the population proportion. So the population proportion is expectation of what? Of H when H follow the vectorial distribution. Right? So when H follow vectorial distribution, of course we will suppose that n is large. Because when H follow vectorial distribution, we have mu equal P, sigma equals square root of P 1 minus P. Right? So P is the mu when X is the vectorial. Right? So the formula H bar become P hat plus minus epsilon. We only consider one case. It means that n is large. Right? Yeah, the second case. So P hat plus minus epsilon is g alpha over 2 multiplied with s over square root of n. What's the s? S estimate of sigma. Sigma is square root of P1 minus P. So what is the estimate of P1 minus P? P hat 1 minus P hat. Okay, we finished the project. And for this section, the third formula you will recall the formula of the sample size, the required sample size. So we find n, such as the error of CI epsilon smaller than the given value epsilon naught. We replace in this formula to find n. Okay, we finish the fourth chapter now. We go to the fifth chapter, hypothesis testing. You remember the chapter hypothesis testing?
Yes.
What are important? The first step, you state S0 and S1. What S1 and what S0 and S1? S1 based on the data of the sample. Remember, the data and the sample always support S1 and S0. An opposite hypothesis with S1. Okay. And when you make a decision, okay, testing hypothesis, so we must make a decision to accept or reject, to accept which the hypothesis, to accept S0 or to accept S1. And when we make a decision, there are how many outcomes? There are 4 outcomes, 2 correct decisions and 2 incorrect decisions. When we record 2 incorrect decisions, 2 incorrect decisions is a type 1 error and type 2 error. What's the type 1 error? Reject S0 when S0 is a true, or we accept S1 when S1 is false. And then we must control type 1 error, because it's dangerous, we will control Taiwan error a given value alpha, right? And alpha is called
level.
the level of significance. We usually consider alpha is 1%, 10%, or 5%. Right? And what the probability of type 2 error? With accept is not when it's not exposed, or we reject S1 when S1 is true, and the probability is equal beta divided by beta. And remember that if alpha decrease, then beta increase, and if beta decrease, then alpha increase. Right? So we will control one out of these two probability. Right? The question why we control probability of Taiwan error. Why?
More dangerous.
Okay, look at the definition. Taiwan error, we accept S1 when S1 is false. Remember S1 based on the data, S1 is mean. So I state that I am true but not false. That's one. Beta, we reject S1 when S1 is true. I am false, but in fact I am true. So type 2 Taiwan error is more dangerous. Taiwan error. More harmful or dangerous. Là type 2 error. And the third outcome, we focus on the third outcome, is the power test. What power test? It's 1 minus probability try to wear. Because I said I am true, and in fact I am true. So accept S1 given that S1 is true. Okay, now we told you the decision rule. What decision rule? So test we will reject S0 when if the observed value of the test statistic belong to W alpha, then we reject S0 and accept S1. Otherwise, if the test statistic does not belong to W alpha, then we fail to reject S0. It means that we do not accept S1. There is a rule, and In our course, we study how many digits in row? We study 24 digits in row. What are they? In Peter, we study 4 tests. What is the first test? Test on me, test on P, test on V1 minus V2, test on V1 minus V2. For test on me, how many digits are there? There are 9 digits in group. Test on P, there are 3 digits in group. Test on V1 minus V2, there are 9 digits in group. And test on V1 minus V2, there are 3 digits in group. So in total there are 24 digits in group. Okay. Now for these 4 tests, I will record 1. And for the other, for the remaining 3 tests, we told you revise. Okay, for each test, you should record the following. You should draw the following G. You draw a G. Okay, the first test on wind. Okay, the first what is the number test is? Mu is mu naught against S1, mu greater than mu naught or smaller than or equal to. And then what second step? The first step we stated on S1. The second step we state the assumption. There are 3 cases. What are they? The first case, sigma equal V8 is known, and under the 2 requirements satisfied, X is normal or n is large. The second case, sigma is unknown. The third case, sigma is unknown. And n is large. X is normal. And then what is the third step? Or the test statistic. What is the test statistic for the first case? We use the Z naught. Z naught is sigma minus mu naught over sigma divided by square root. And when S naught is 2, under S naught, it follows and 0. So what is W alpha? The reason okay, we write it. W alpha equal for the Ramacher test from the alpha to infinity if S1 will greater than mu naught, smaller than differ from smaller than from minus infinity to minus Z alpha. From minus infinity to minus Z alpha over 2 union Z alpha over 2 to plus infinity. And we call this is the rule 1, this is the rule 2, this is the rule 3. Okay, you can recall the second and the third case. What's the second case? What's the statistic for the second case? T naught is x bar minus mu naught over n divided by square root of n follow. Steven is wrong. N 0 1. Okay. So n is large. So the reason is W alpha identical the first case because we use n01 and we define the residual number 4, 5 and 6. When C by some and X normal. The statistic T naught x bar minus mu naught over n divided by square root of n follow n0 Tn minus 1 under x naught. So what W alpha? We only replace the z value by Tn minus 1. We replace z by t minus 1. So you remember formula W alpha in the first case. And for this case, we have 4 3 decisions. This is rule 7, 8, and 9. And the first test on we, and then the second test on P you do similarly. You draw a T. For test on P or P1 minus P2, P1 minus P2. On P or P1 minus P2 or P1 minus P2. Okay. 2, 3, and 4. Okay. I told you before the test on P or P1 minus P2 and of course in the final exam we will choose one of these 4 tests to ask you. And maybe we can ask you to find beta or 1 minus beta. Explain the meaning of the significance or explain why we control the probability calculated. Okay, now we call the last chapter, the 6th chapter. Chapter 6. The simple linear reaction. Simple linear reaction. So this model is given by the equation y is beta naught plus beta 1 x plus epsilon. And the data or the sample factor consists of n value n point x1 y1 x2 y2 to xn yn. the model. We have an equation. Yi is beta naught plus beta 1 plus hi plus epsilon n. For I range from 1 to n. And what is the assumption of the model? What's the assumption in the model? Epsilon I, IID, 0, normal with mean 0 and when sigma square. The assumption. And and epsilon I are dependent. It means that the covariance between xi and epsilon I is zero. The independent variable and zero variable are independent. Here's the assumption. Okay, so for the simple linear regressive model, when you do this exercise, the first step, we compute 5 variables. The sample mean x bar, then y bar, and then we compute 3 sample square, SS, xy, SS, xx, SS, y1. What is xy? The sum of hi yi minus n h bar y bar. The sum of hi square minus n h bar square. The sum of yi square minus n y bar square. Okay. And the first question, we ask you to find the least square reduction line or the estimated reduction line. The estimate of beta naught and beta 1. To find the estimate of beta naught and beta 1, you can apply one or two methods. The least square method or the maximum likelihood estimation method. The question 1. We compute estimated or the least square reduction line y hat equal beta naught hat plus beta 1 hat x. When what's the beta naught hat? Beta 1 hat SS xy over ls, xx and beta naught hat is a y bar minus beta 1 hat x bar. This is the place. The second question, we find the estimate of y or of the mean of y given x, given that x is x naught, the factor is y hat beta naught hat plus beta 1 hat multiplied with x naught. In this equation, you will replace x by x naught to estimate y or the mean of y. Question number 3, we find an unbiased estimator of sigma square is a variance. Right? What is the estimate of sigma square? Variance of epsilon. Is S epsilon square. Is LSE divided by n minus 2. over n minus 2 multiplied with ls yy minus ss xy square divided by ls xx. And question number 4. We compute the coefficient of incumination r square is ss xy square divided by ss xx ls yy. And the meaning of r square measure what? The percentage of the variation, the percentage of the variation of y that explained by the model. It means that by the independent variable x. And the meaning of r square. And the last question we can ask you, we test on beta 1. In the case of beta 1, we have H not beta 1, beta 0 again. Beta 1 positive or negative or different forms. So what test statistics for this test? It's the T naught. It's the beta 1 h divided by S beta 1 h. Follow Steven distribution with 2 and minus 2 degree period under S naught. So we have W alpha from T n minus 2 alpha to first degree T for the Y test, for the left test, and for two test. The region is in W. There are 5 questions, 5 formula of the C-chapter, the C498 chapter. And this chapter are not difficult. So when you do the exam, when you do the final exam, you should answer this the C-chapter first. Okay, we have revised all the important content of our course. In the final exam, we will ask you C-chapter. So to get 10 points, of course, we will study full content. I think it's more important for you to remember the theory. But if you get 10 points at the final exam, but you cannot write all this content because it's not important. It's better if you can revise on this content. So I'm getting 10 points at the final exam. Bạn nào mơ gì nhỉ? Ngồi 90 phút mà viết hết từ đầu đến cuối được như này thì chúng ta sẽ trả được mình. Thì chúng ta cuối cùng các bạn học xong rồi môn học ấy, học xong là cái gì? Nhưng tức là trong đầu ta có cái gì? Không phải quan trọng ta đi chỉ 10.
Ganti
Is that question?
gì ạ? Khi nào tin đấy ạ?
You got a question?
Cũng có một sự phùng với Linh.
Okay, if you have